Hello students, in our DME class, today we will start a new chapter and this chapter is springs. So we will discuss some of the introduction part and theory topics of the springs. A spring is defined as an elastic body whose function is to distort when loaded and to recover its original shape when the load is removed. So when we apply load on the spring is stretched or compressed. We can say it is distorted. And when we remove the load, it retains its original shape. The various important applications of springs are as follows. So first application is to cushion or absorb or control energy due to either shock or vibration, as in car springs, railway buffers, aircraft landing gears, shock absorbers, and vibration dampers. So as you see in your automobiles, you use springs to absorb the shocks and vibrations, and in your machines you use shock absorbers, and railway buffers are used to absorb the shock and vibration dampers. Second application is to apply forces. As we have seen in brakes, we use springs, in clutches we use springs, and in spring loaded valves we use springs. To control motion by maintaining contact between two elements, as in cams and followers. So in cam and follower we also use springs. To measure forces, as in spring balances. To store energy, as in watches, toys. So these were the applications of the spring. Now what are types of springs? Though there are many types of springs, yet the following according to their shape are important from the subject point of view. First type is helical spring. You can see in this diagram there are two types of helical spring. One is open and the other one is closed. Helical springs are made up of a wire coiled in the form of a helix and is primarily intended for compressive or tensile loads. So actually it is a wire which is shaped in the form of a helix about an axis, and it is intended for compressive or tensile loads. Two forms of helical springs are compression helical spring and tension helical spring. The helical springs are said to be closely coiled when spring wire is coiled so close that plane containing each turn is nearly at right angle to the axis of the helix. So in close coil helical spring, the wire is closely coiled and the plane containing each turn is nearly at right angle to the helix. So this you can see the close coil helical spring, there is no gap between the coils. In other words, in a closely coiled helical spring, helix angle is very small and it is less than 10 degree. So as you can see this angle is less than 10 degree in case of close coil helical spring. Major stresses produced in the helical springs are shear stress due to twisting. So when we apply force on the spring, on a helical spring, the stresses produced is by twisting, that is shear stress. In open coil helical springs, spring wire is coiled in such a way that there is a gap between two consecutive turns. So in open, this is open type helical spring, and there is a gap between the turns and helix angle is large. After helical spring, there is a second type of spring, that is torsional springs. The construction of this spring is similar to that of compression or extension spring, except the ends are formed in such a way that the springs are loaded by torque. So the construction is similar that of the helical spring. You can see it is a helical spring as well, but its ends are shaped in this form, L form. Okay, so that when we apply the force on it, it will be a torsion spring. Generally used in door hinges, you have seen in your doors, door locks. Bending moment induces bending stress in the spring wire. So the spring wire will be subjected to bending when we apply force on the torsion spring. Laminated or leaf springs, these are used in heavy duty trucks. Laminated or leaf springs, also known as flat spring or carriage spring, consist of a number of flat plates known as leaves. So these are number of flat plates or leaves of varying length held together by means of clamps and bolts. So you can see we have used a bolt to engage these plates together as shown in figure. There are mostly these are mostly used in automobiles. Longest leaf is called master leaf. The upper one, which is the longest leaf, it is called master leaf. It is bent at two ends to form the spring eyes. So you can see this is the bend and you can call it the spring eyes. Now some of the important terms used in compression spring. First one is solid length. What is solid length? When compression spring is compressed until the coils come in contact with each other. So when we compress this is open coil helical spring, we compress it and we compress it up to the stage when there is a no gap between coils. Then the spring is said to be solid. This spring is called solid, and the solid length of a spring is the product of total number of coils and diameter. This spring is called solid and its length is called solid length. And it can be obtained by the diameter of the wire multiplied with the number of turns. So solid length ls is number of turns, n dash total number of coils, and d is the diameter of the wire. Second thing is, what is free length? Free length of a compression spring as shown in figure is the length of the spring in the free or unloaded condition. So in this diagram you can see when we do not apply any force on the spring is fully open, or we can say free, and at that moment the length of the spring is called free length. It is equal to the solid length plus maximum deflection or compression of the spring and clearance between adjacent coils when fully compressed. So free length can be obtained by adding solid length and maximum deflection and clearance between adjacent coils. So free length is solid length plus maximum compression plus clearance between adjacent coils, solid length n dash d plus maximum deflection delta max plus this is empirical relation for the clearance 0.15 into delta max. Spring index, it is called d by d, which is written as capital C. Spring index, important term. Capital D is the mean diameter of the coil and small d is the diameter of the wire. So you can see this capital D, diameter of the coil, versus divided by diameter of the wire is called spring index. Spring rate or stiffness is defined as the load per unit deflection. So K is written as load per unit deflection, W by delta. Rest of the things we will discuss in the next video. Thank you.